Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face Trending List, published on July 19, 2025, just 3 days ago. This paper introduces a new series of fully open-source models that achieve state-of-the-art performance on some really tough mathematical reasoning benchmarks. The paper is titled MiroMind-M1, an open-source advancement in mathematical reasoning via context-aware multi-stage policy optimization, and the novel training algorithm they developed is a big reason for these results. The author's main goal is to boost transparency by releasing everything, including their models, datasets, and all training configurations. Also, the authors shared their work on GitHub, and it's a really complete package. Listeners will find everything needed to get started, including the full scripts for supervised fine-tuning, reinforcement learning, and evaluation. It's great to see a project this open, letting you replicate their results or build on them. And on Hugging Face, you'll find the models ready to go. Both the 7 billion and the larger 32 billion parameter versions are openly available for download and use. So, how did they get these impressive results? The table of contents here lays out their whole approach, which is a two-stage process. First, they use what's called supervised fine-tuning. This is where they take a base model and further train it on a huge, carefully cleaned dataset of math problems with step-by-step solutions. Then, for the second stage, they use reinforcement learning. Here, the model learns by trial and error, getting rewards for correct answers. This is where they introduce their new method, context-aware multi-stage policy optimization, or CAMPO. So diving into that first stage, the supervised fine-tuning, this figure really highlights a key part of their strategy. It shows the length distribution of the different datasets they used. The length here refers to the number of tokens in the step-by-step solution, or what's called the chain of thought trajectory. You can see their own dataset, in dark blue, is shifted towards longer, more complex problems compared to others, like the synthetic dataset. This focus on longer reasoning chains was crucial, as it led to big performance gains during this initial training. This table then details the specific datasets they used for that supervised fine-tuning stage. It shows the number of questions, and the number of step-by-step solutions, which are called reasoning traces for each source. And what really stands out is their own curated dataset. At the bottom, they assembled a massive 719,000 high-quality reasoning traces, and used all of them. This is a huge number, especially when you see how they filtered other datasets, like synthetic one, to maintain quality. This careful data curation is a big reason for their model's initial success. Alright, so after that initial supervised fine-tuning, the authors move to the second stage. This is where they use a technique called reinforcement learning with Verifiable Reward, or RLVR. This basically means the model practices solving problems and gets a reward, but only for answers that a separate tool can confirm are 100% correct. This chart shows the dataset they built for this process. It's much smaller, just over 62,000 problems in total, because they were extremely selective, filtering out 94% of candidates to keep only the most challenging and reliably verifiable questions. Moving to the results, this table really puts everything together. It compares the MiroMind-M1 models against other models on tough math benchmarks like AI 24 and Math 500, and the results are impressive. Their 7 billion parameter model, the MiroMind-M1 RL7B, scores a 73.4 on AIME 24, beating other models in its class. The larger 32 billion parameter version also achieves a very strong 77.5. These scores really validate their whole two-stage training approach, showing it produces highly competitive, state-of-the-art results. And this next chart gives us a fantastic look at that reinforcement learning process in action for the 7 billion parameter model. We see its accuracy on the AIME 24 and AIME 25 benchmarks steadily climbing as it goes through more training steps. The training is split into two parts, Stage 1 and Stage 2. This is their new method, context-aware multi-stage policy optimization, which trains the model progressively, allowing it to generate longer solutions over time. The final scores, marked by stars, clearly show the steady improvement and validate this multi-stage approach. So to wrap things up, The MiroMind-M1 models really showcase the power of this careful two-stage training. The combination of supervised fine-tuning and their context-aware multi-stage policy optimization not only achieves state-of-the-art results, but also improves token efficiency, meaning the models generate shorter, more concise answers. And just as importantly, by releasing everything as open source, the models, the datasets, and the configurations, they're making a fantastic contribution to transparency and reproducibility in AI research. That's all for today's AI Research Roundup. Thanks for tuning in.